Today, we are diving into Kafka Connect, the powerful no-code integration framework that allows you to stream data into and out of Apache Kafka with ease. If you have ever wished to connect Kafka to systems like MySQL, PostgreSQL, Elasticsearch, or MongoDB without writing custom producer or consumer code, Kafka Connect is exactly what you need. Kafka Connect is part of the Apache Kafka ecosystem. Its job is to move data between Kafka and external systems reliably and at scale. Think of it as plug and play for Kafka integration. No custom code needed. It supports scalable, fault-tolerant pipelines with built-in connectors. To make Kafka Connect do something, you must register a connector through the REST API endpoint. There are two types of connectors. The source connectors that bring data into Kafka by reading the data from a source. For example, let's say in our case, it will read data from PostgreSQL and write it to Kafka topic. And then we also have the sink connectors that consume data from Kafka topic and write it to a destination. For example, in our case, it will read the event from Kafka topic and write them to Elasticsearch. That way, without writing any code, you have your source and sink connectors consuming the data from your tables and then writing the data to your Elasticsearch. I want to thank you all for watching this video. Don't forget to like, subscribe, and share. Let's continue. Let's start by looking into our Kafka Docker Compose. If you have watched any of my previous videos, the Docker Compose I used there is the same Docker Compose or setup or environment that we are going to use here. With a small change, I added like an external name volume for every node in the cluster. I will share all these files on the repository so you can take them from there and then analyze and do whatever you want with them. I have also started the Kafka cluster here. As you can see, the cluster is already running. Next, I have also created a Docker Compose with Postgres, Elasticsearch, and Redis databases. This is to have both source and destination for Kafka Connect. As you have seen, we are going to use Postgres as our connect source and Elasticsearch as the destination for the connect sink. I have Postgres here. I also have Admina just for UI stuff. And then I have the Elasticsearch, and then I have Redis. We are not going to use Admina and Redis in this video, but I just put them there to be ready in case of the next or future videos. I have also mapped all the volume to an external volume, as you can see. Well, as I said, I will share the files, then you can take them and look into the files. Next is the Connect cluster. You might be familiar with most of the configuration if you have used or written Kafka consumer or producer before. The ports that you can see here is what we are going to use to interact with the Connect cluster. And another important point here is how I map the volume or the plugin directory to an external named volume. Here, the external volume is mapped to my local host, and there I download all the jars that I needed, that is the source and the sink jars, and then put them in that directory so that when the cluster or the Connect cluster starts, it will scan that directory and then use the plugins. And as you can see here, I have just a 2-node cluster, and there I have specified already the plugin part and the volume it is going to use for the plugins. So this is all you need. Now the cluster is already running. We also have our databases already running, both Postgres and Elasticsearch, and then the Connect cluster is already executing, is already running. Before we go into looking how to use the Kafka Connect, there is one thing I want to say here, and it's about the installation of the plugin. I will really recommend using the Confluent Hope client to install or download the plugins, because with the Confluent Hope client install command, it also downloads all the dependencies of the plugin. For example, here as you can see, I use these two commands to download or install Elasticsearch and JDBC plugins. These are the commands if you already have the Confluent Hope client installed on your system. And with this command, it will download and use it. The one weird thing that you might have seen is the worker config, which is really required, which is your Connect Worker configuration property file. If you are installing the plugins to an external location, like as I do, then you can create a dummy file and use it as I did in these commands. It is just to trick the installer to let you install the plugins without providing the actual config properties file of your Connect cluster. Okay, before we go deep into Kafka Connect, let us first look into Postgres. That is our source of data. And now if we look in the Postgres, I just create a simple two tables, payment and cat. In payment, I only have one record, and in cat, I have two records. Simple. This is our source where Kafka Connect is going to read the tables. Then we also have Kafka. I already have two topics, payment and cat. Here, I can check and see, is there anything in the payment? No. So currently the payment topic is empty. And also the same thing I can do to check for the cat topic. Also cat topic is empty. The next thing we are going to look into is Elasticsearch, because that is where Kafka Connect is going to write the data. So we can also check Elasticsearch. Yeah, I just have some simple scripts here and then set up the local host, and I will try to list all the indices in Elasticsearch. And when I list them, you see I have two indexes, the payment and the cat. That is where our Kafka Connect is going to use as the destination. That is where to sync. And if I check this payment, let's go and check the payment index now. And you can see it's empty. The same thing, I think, for the cat index is also empty. We have our data in Postgres that is waiting to be moved to Elasticsearch, and we are going to use Kafka Connect to do that. Okay, let's deep dive more into the Kafka Connect. We are going to start with the source connector. The Kafka Connect JDBC source connector is table oriented and not relationship aware. It does not perform joins across tables or handle relational navigation automatically. So by default, each table map to one Kafka topic. If you have, for example, a table named payment, as we do, then the Kafka topic will be payment. Here you can see a simple example of connector that we are going to execute, and here we are whitelisting all the tables the connector is going to be reading. So here it will read all the data from these tables that I listed and then write those data or events to Apache Kafka. Also, as you can see here, the mode is incrementing, which means the connector is going to be using ID to determine new records. Let's create the connector now. After executing the run command for the create source connector, you can see like the source connector is already created with a task of 1. And when we come back to the connect console, you can see like it's already read the records. Now it's sending more requests but no more record to read. If you can see here, the current result is null because it has read the 2 records already from cat and then from the payment. And how do we know that? We have checked previously our topics were empty. Now let's go back and check the topic. For example, let's check for cat using consumer console. You can see now we already have record in cat topic. And also likewise, if we are to go to payment topic, let me just change the name to payment, and you can also see that we have our record in the payment. So now the records are already in the topic. Because we did not create our sync connector yet, then the record shouldn't be in Elasticsearch. Let's check our payment index, and you see still our payment index is empty. The same thing if we check for the cart index, you can see the cart index is also empty. Currently we only have our source connector but no sync connector. Source connector read the data from Postgres database to Kafka cluster, which is to our payment and cart topic. Then the sync connector will read from the payment and cart topic and then write the same data to Elasticsearch. So now Elasticsearch is empty. Let's go ahead and also look into the sync connector. Before we continue with the sync connector, I have to also let you know that you can configure the connector to run a custom SQL query using query instead of the whitelist or the table whitelist. This is an example of what you can do if, let's say, you want to join many tables and just write the data in single topic. Of course, there are other additional configurations that you can add to your source connector or to your sync connector. For example, you can use a prefix if you want your topics to have a prefix to the table name, or if you want to detect table update, you can also use mode timestamp and timestamp.column.name, such as updated at instead of incrementing only. And that means your table must have the updated at column for the connector to be able to detect the update. You can also use mode timestamp plus increment, and that way this will let your connector detect both insert and update on the table. And you have to ensure that you have both the increment column name, such as the ID, and then also timestamp.column.name, which the connector will use to be able to determine when a new record is added or when a record is updated. For more complicated tracking, such as insert, update, delete, really you have to use connect alternatives such as the Vision. Okay, we are almost there. Now we are going to look into the sync connector, or how to create the sync connector for the Kafka Connect. By default, it can consume from multiple topics. So when you start this sync connector, it will consume from the topics you listed here in the topics, and it creates one index per topic. E.g., if you have payment topic, then it will create an index in Elasticsearch for that topic. One-to-one mapping, one topic, one index. This is our sync connector. Let us go ahead also and run the connector and see what will happen. Okay, we have now created our sync connector, and we are now going to have all our record on Elasticsearch. If we come back to our Elasticsearch query before the one we checked before, okay, of course this is just to check for the index which we have, and you can see even the size of the index have changed compared to when we check it for the first time. So now if I just query the payment index, I should see something, right? And you can see like now our data is also in the payment index. Also, if I check the cat index, we should also have the cat record, and you can see, yeah, we also have it there. So this way, automatically, when you set up your Kafka Connect cluster, it will always read the inserted record from your source and then write it to Kafka topic, and the sync connectors will read it from Kafka topic and write it to the destination or wherever you want it to go. And this way, you don't have to write any code. You just put it there, leave it, and everything will be working as expected. Well, I know I'm bugging you with a lot of files, a lot of bits and pieces, but I will share everything on GitHub and then share the link so that you can take and check all the files and try to do it yourself. So now let's look into some of the useful endpoints related to the Kafka Connect. For example, okay, this is just to set the base URL on the bash, and then if I just set it, then I will be able to use that. Now I can check list of my connectors by running this, and you can see I have two connectors, the source and then the sink. Or you can also delete a connector by giving the connector name. For example, I have two here for my source and sink. Or you can check the status of your connector. You can check what status it is. You can also check, you can pause a connector. You can also resume the pause connector. You can restart it in case of any problem. So these are also some of the endpoints, and I will share the files so you can also go and do or play with them and see what is going on. Kafka Connect bridges Kafka with the outside world, let's say code free, whether you are syncing databases or archiving to S3. Kafka Connect gives you plug and play stream pipelines. Thank you for watching this video. If you want hands-on demo, follow along with upcoming tutorial. See you next time. Bye bye.